Alright, so in this problem, we want to find the intervals on which the function is increasing or decreasing. Before everything else, we have to check the domain of our function. Here we have the natural logarithm of x, which means that x has to be greater than 0. And here we also have 1 over x, and because of this, we know that x cannot be 0. So, what we can say that on the number line, this is how our domain will look like. We want to find the intervals on which the function is increasing or decreasing, and for this, we have to apply these rules. So first, we have to find the first derivative of our function, which will be 1 over x minus 1 over x squared. To find the critical points of the original function, we have to solve this equation here. First, we factor out 1 over x squared. So the other factor will be x minus 1. From this, it is clear that a critical point will be at 1, which is here in the original domain. Okay. Now we have to make our table just like this. Here we have the first derivative and the original function. Okay. We've already seen that at 1 we have a critical point, so we write a 0 here. And what we have to do now is to check the signs of the derivative before and after 1. For this, we have to take a look at this one. Okay. If you look at this, it is clear that this factor will be positive. So we have to graph this function here, which will look like this. And as we can see, since before 1, the graph is below the x-axis, it will be negative. And since after 1, the graph is above it, it will be positive. So for this interval, we can write negative, and for this one, we can write positive. Okay. But since we know this, we also know that our original function on this interval before 1 will be decreasing, and on this interval, it will be increasing. Though it wasn't a question, from this, it's clear that our function will go like this, which means that at 1, we have a local minimum place.